this technical lecture is the inaugural one for minimal intervention. Less is more. Minimal intervention is the new award category introduced this year by FIStructE for the annual awards. And it comes off the back of a number of things, one of which is the work we've done on Newquay Harper Footbridge that won the Heritage Award last year. So wanted to go through that. It's been an incredibly difficult thing to try and put into slides and put into a presentation, because how do you describe minimal intervention? So I'm going to give it a go and see how we get on. So a little bit about freeform consulting. And freeform is, it's called a network practice, network-based. So we were established in 2009, currently located in 5 countries, and as I said, are a network-based practice, meaning no fixed office. So the COVID thing hasn't really affected us much, in the sense that we understand the entire team work from their premises, their own homes around the world, and we've been working this way for the last 10 years, paperless, and we're an e-practice effectively. We won we're shortlisted for the IC London Awards last year for 2018, Team of the Year and Company of the Year. Won obviously last year the Heritage Award for Newquay Harper Footbridge. The same footbridge was shortlisted for sustainability, and I sit on the Structural Futures Committee, the Design Practice Committee, as Michael said, and I chair the sustainability panel. I'm also an interviewer for the Part 3 if anybody's interested in going for the Part 3. There's some images there of the sort of thing we do. I mean, it's not exhaustive, but it's to give you an idea that's a glulam and a CLT structure at the top there that's in Singapore, Newquay Footbridge to the right, an industrial building that in Ethiopia, and the various bridges in London that you possibly recognize. Some of you may know the Illuminated River project that's on site at present. FM Conway are the contractors for that one, and we are working with them. So that's a little bit about freeform. Now, minimal intervention, less is more. And what does that even mean? It's a difficult question. Hang on, there we are. Why bother to promote something like minimal intervention? Because the question is, aren't we already doing only what's necessary? As good engineers, with inverted commas on the word good, and all of us on the call, if we're engineers, are good engineers, are we not already doing that? Why does this have to be a category by itself? And then the other thing is, for those of us who are influencers or have any degree of seniority in our various companies, doesn't this go against the grain of business development? I mean, why is doing the minimum the right thing to do? Well, maybe we're already doing this, is a question. And I think possibly. I did, my original slides had the word no, but I changed it to possibly, because as engineers, we face differing priorities. And if you are a principal, if you are an associate, if you are any of those things, in whichever company you're in, then profit is the motive. And for the larger organizations, or for any organizations, frankly, protecting the PI is a consideration. We don't like to think of it that way, but the reality is it is a consideration. There are also consultant politics or consultancy politics. And this is something I've come across where one particular office of a larger organization has produced a design, and it cannot be questioned by a checking arm or a subsequent arm within the same organization because of the internal politics of that organization. Client politics. Client and politics often go together, more so if your clients are local authority. Politics is a part of it, and the difficulties local authorities face in satisfying the public, in answering the reputational issues. So that has something to bear on it. Again, these are all issues that personally I've faced. That's why it's in there. Prowess or reputation. Getting a name for something. This is what we always do. We've got a brand. It's almost like cookie cutter. So minimal intervention isn't a phrase that we know readily via FIStructE, EIC, or any other organization. It is this new award category, and rightly so, I think. Minimal, I've just put, is removing the least we can and inserting the least we need. Now, for those of you on the webinar who have anything to do with climate emergency will recognize maybe not the phrase, but certainly the sentiment. Removing the least we can and inserting the least we need. Intervention, I said, most likely lends itself to existing structures, but not always, as we'll see as we continue. So, moving on. What it isn't. Minimal intervention isn't a design code. You won't find it. It's not a legal requirement. It's not enforceable. I don't believe it's the enemy of growth or business development. I'm going to try and get that point across in this webinar. If I'm successful remains to be seen, but I don't think it's the enemy of growth or business development at all. And it certainly isn't a tacit agreement to take things at face value. What isn't in this, actually, let me do the next slide and then I'll come to what it is. On the FIStructE's website, in the old days, it used to, I sound quite old now, but in the old days, it was said to design with economy. That phrase is gone, but this phrase is in there. What is a structural engineer under the What is a Structural Engineer tab? Structural engineers are a problem solver. Structural engineers use many skills to solve problems, from basic maths to cutting edge technology. They work to design sustainable structures, that is buildings that are larger and longer, but use less material and require less maintenance. And I've highlighted and underlined, but use less material and require less maintenance, because that is minimal intervention. It's there. It was always there on FIStructE's website. It's a series of filters that we apply rigorously. It's a place of innovation. I believe it is. And I know we all think of our practices as being innovative, and again, probably rightly so. But something that is a phrase that is not on the slides, but it is appropriate, it's that I've tried to distill it down to what I think it is, and coming to the conclusion that it's listening appropriately to all the information that's coming your way. So for the client particularly, it's not that middle line between not listening at all and giving the client what you think the client wants, and listening too much and going down a blind alley with what you think the client wants. Because quite often, as I've found in my experience, clients are using language that they've inherited from poor advice historically as to inform us as designers. And if we take that at face value, then we could be into problems. So I just wanted to discuss what drives the solution. And I think there's only one thing that drives the solution on minimal intervention. That's the designer, us. How do we see the world? Do we always have to trade up? And what pressures are we under? That's key, because there's the whole thing about trade up. That is a phrase. It's a phrase I learned as a graduate many years ago, when the principals or the directors of a company wanted to grow a project, if you like, to use that phrase. Is that the same thing as, or does that chime with minimal intervention? Maybe not. But if we see the world as being big enough that all of us have a place and there are enough projects to go round, and it's not a zero-sum game, which is another way of saying not only I must win, but you must lose, then no, it's not the way we see the world. So what factors influence minimal intervention? History. We can learn from history, and I'm going to show that in our case studies. I want to get to the case studies. The budget, that's obviously something that will shape how much we do. The function, what do we want the structure to really do? And that's where we can challenge clients and say, what do you really want this to do? And again, we can have a look at the case studies. Innovation, we can learn from other industries, not just the Structural Journal and NC and so forth are great showcases of where new innovation is coming out, and case studies and whatever. But there are other industries we can learn from, as we'll see from the seminar, from this webinar. Climate emergency. That's going to be right the way through. The same old is not good enough. Politics, as we talked about, and also someone's ego somewhere. Actually plays more of a part than we probably give credit to. I'd like us to have a look at this graphic. And it's something that has been banding around recently, and it couldn't be more right in this age of climate emergency and with all the committees that I'm involved with and chairing sustainability. It is the thing right now on anybody's lips within REBA, ICE, FIStructE, IET, and so forth. Royal Academy, all of them. Bringing this to a human scale, going vegan will reduce your carbon footprint by around 2 tons per year, for anybody who's interested in going vegan. A typical structural engineer, now this is typical, responsible for 4,000 meters square of new buildings per year, at a typical carbon footprint of 250 kilograms, and that's modest, by the way, is responsible for 1,000 tons of carbon per year. Every 1% saving that we make as structural engineers is 5 times more than going vegan, or 5 people going vegan for a year, or 10 times more efficient than flying to New York. That's 1% of our saving. That's saving 1% of concrete, 1% of steel, 1% of anything that we do. And including, as we'll see in the case study, 1% of getting people to do things more than once. Getting it right first time, in other words. So let's have a look at a graph. This is based on years of research and data. And hopefully you can see that there. There's lots of numbers that has gone into that. And essentially, I don't have a pointer on this, but we can see I've color-coded it, which is, it's just a time versus money graph. And the idea, if we work from the bottom left, not much funds, you can have lots of funds, but not much funds and a reasonable amount of time. And that's where minimal intervention lives. And I say not much funds because generally you're not spending an awful lot because we're doing less. And then we go to the right-hand end of the scale in red, where we've got loads of money and not much time. And that's like Armageddon or COVID-19, where the Chancellor's promised whatever it takes for the NHS, or The Core, the movie, where, well, as you know, anybody who knows these movies, you're going to spend loads of money in a very short space of time because it's an emergency. The humanitarian projects at the top, not a lot of money, but this is digging wells somewhere or creating a school somewhere. Lots of time on your hands, but it doesn't have a great budget. That kind of lives up there. And everybody else is kind of in the orange patch where we've got a fair budget and a fair amount of time. So that's the spread of where it's going to be. Just want us to have a look at this, and hopefully you should be familiar with it.
Dr. Brazelton, when do you think the ship will be operational?
When I get my fabrication methods perfected, 12. 10 years, 10 years.
What would it take to get it done in 3 months?
$50 billion.
Will you take a check?
There we go. So, familiar clip from I love movies, and that's a good one. If the science is to be believed, but that's a kind of COVID-19 moment, isn't it? Where there's loads of money available because a problem needs to be solved very quickly. I'm going to play another clip, and I'm going to ask you to keep your eye on the chewing gum. There we go. Chewing gum saved the day. So the thing about those clips was just to illustrate the different problems, and on the second one with the drone, obviously, hopefully that's you recognize it from the film Oblivion. The chewing gum was the one that made the drone work because he stuck something in place. It's minimal intervention, but that's where the character sees that as being what's appropriate to do, and that's what this is. It's about what's appropriate to do. So I think the best way to describe is to see it in action. So let's have a look at these. This is the project that won the Heritage and was shortlisted for sustainability last year. It's Newquay Harper Footbridge, and we've got 4 case studies to get through, so we'll shoot through them. And moreover, I want to explain that this is not going into the minutiae of the technical solution. This is about the process. So if I gloss over technicalities, that's intentional. It's so that we can see the process that got us to the answer. So the immediate thoughts are, it's elegant, you can see that. It's historic, it's over 100 years old. So it has all the hundreds, this one. It's 100 years old, it's 100 foot long. It's in a very difficult location. Temporary works is going to be an issue. Very aggressive environment, sea blast and what have you, high winds. It's privately owned by a lovely couple that have the house on the island. And there was a low budget, meaning compared to what I would say is required for a bridge. If you think about highway authorities and bridges, the clients, I believe, certainly it's a personal opinion, were poorly advised initially. So if we get into it, the problems are that some work done a few years ago replaced the hangers with the original carbon steel hangers with these stainless steel hangers on the advice of someone else. And what it was doing was harming the bridge with bimetallic corrosion. We can see that in the second photograph from the left. But moreover, third photograph from the left, and we can see that it didn't even centrally locate the forces. It put a moment or a twisting on the cable. So not a great solution, but primarily, although those hangers would have lasted forever, it would have corroded the main catenary and caused the bridge problems. So our approach was to look at the history of the bridge, and we compiled a compendium of photographs dating back through the years, from just a blob of rock to a building appearing, actually just I think animals appearing, just grazing, and then a building appearing, a tea shop, and then it became a house and so forth. We looked at, so we researched the history of the island, researched the history of the Harper bridges around the world. It was sold as a kit. It was easy to put together, simple details, lots of articulation. We engaged the grandson of the bridge designer and the originator, Louis Harper, Douglas Harper. Douglas, very much alive in Scotland, retired, and he was engaged as a consultant. He wrote a book on his grandfather's bridges. We agreed on appropriate loading with the client. It's privately owned, and what's appropriate? Throwing Eurocodes at this isn't the right answer. It's a repair, not a new bridge. So what's an appropriate loading? We modeled it and found that there was lots of capacity in the system when the original advice was only the towers can survive. You know, the main catenary, the deck boards, everything's got to go, and the hangers, and so all of that has to change. And we just felt that wasn't the right answer. That didn't ring true. And it didn't ring true either with the owners, I should say. But they couldn't demonstrate that or prove it. So we modeled it. And we only replaced the bare minimum. That's minimal intervention, not just on the permanent works, but also on the temporary works, as we'll see in a minute. So we designed the replacement methodology, and we learned from the ship rigging industry. And by that, I mean we used a ship's rigger to do the works. We didn't use a metal fabricator because he understands bending metal. He understands rigging. He understands shapes. He understands connections. The temporary works on the left, 2 blue lorry straps, are the only temporary works used in changing every one of those hangers. I think it was 90 something or 100 hangers. Can't remember off the top of my head. I think it was 48 each side. And that was the only, just a pair. Work on one hanger, de-stress, remove it, introduce a new one, move on to the next one, so that the geometry of the bridge catenary was maintained throughout. We can see in the bottom left the final detail compared to the little thumbnail there of the original detail, and how elegant the, if I say so myself, the detail is compared to what it's replacing. Lots of articulation, mild steel, carbon steel, painted. 4th bridge principle: if it's good enough for the 4th bridge, it's good enough for this bridge. Keep it painted and it will be fine. And so I can't take credit for that detail that was there. Louis Harper did that 100 years ago. All we did was reinstate it. The middle thumbnail, where you can see some ratcheting of a piece of tool, we develop new tooling for the job. Not expensive, but tooling. The rigger actually developed the tooling to form these loops and shapes, and introduce the woggles, which I didn't know what a woggle was, but apparently from Boy Scout days, a woggle is something that you put around your necktie. So simple temporary works, and we applied asset management principles to finish off the whole thing. What does that mean? We gave the client a care plan. Say, paint your bridge, inspect it once a year, all good practice that we would expect as bridge engineers. And that's what they're faithfully doing. And we go along and do a quick shifty on it once a year, make sure it's all behaving itself. But again, like the Forth Bridge, if you keep it painted, it won't corrode. So that's Newquay Harper Footbridge. Then we have a 130-year-old three-span bridge in London, which got washed away. So historic significance, it's within a parkland setting. It's not listed, but it is historic. And it's a local authority owned, high local profile, I should say. Utilities across it, quite a lot of utilities going across this bridge. Three-span masonry arch, as we can see in the photograph. The client was advised, or a client's client was advised by others that the bridge could not be economically repaired and should be renewed. And that's where minimal intervention comes in, because we think it can be repaired. So what caused the problem? Well, it was a flood event, which was unprecedented. That's needless to say, it was above and beyond anything that the Environment Agency were expecting or have on record. Localized scour caused a footing, you can see the top right there, to give way on one of the abutments, and the whole thing just went south. South as in down towards Australia, not south as in on plan. The arch collapsed and the deck collapsed with it. The middle right photograph is an aerial shot showing the deck falling into a bit of a hole there. And the red you can see is waterproofing that was about to be resurfaced, but never got that far. Temporary dam, which is in the blue tarpaulin you can see there, was introduced to reduce the bridge flow and protect the arch against river currents and stop more erosion. And there was also the risk of more flood events to come at that time. So we had to, it really was emergency stuff. So what we did when the client's client was told, no, mate, you've got to chuck the bridge in the bin and start again because it can't be economically repaired, was we did engage Bill Harvey Associates. Some of you may know Bill or his work. He is easily one of the leading authorities, if not the leading authority on masonry structures and arch bridges. And we carried out a high-def image survey and photogrammetry. So the high-def imagery is a camera going down and stitching together photographs. The software stitched together the photographs and formed the 3D model you can see on the top right. That's just an extract of the 3D model. But the model is actually quite powerful in that, excuse me, you can take slices, which are the 2D slices on the right there, showing precisely where the damage is along the barrel of the arch. So we did all this with Bill. And the third bullet point there is an interesting one. Actual arch geometry mapped, proving the arch forms weren't perfect to start with, but were strong nonetheless. In other words, a client believes that their bridge is as the day it was built. It's not. It's reshaped a wee bit. And the photography shows that. Pre-damage of the bits of the bridge that weren't damaged, we can show that the arch geometry, whilst not being perfect, has an awful lot of strength. You know, masonry structures are incredibly forgiving. So what that meant was we could do a viable repair options. We came up with two options, in fact, which were accepted ultimately as viable and economic and were put forward. Whether it was adopted or not is not our call. The point is that it's demonstrable. It's possible to repair this thing. And compared to a new build in concrete, we showed that only repair that which is damaged. You don't need to chuck the whole thing in the bin. The repair, compared to building a new bridge, is a lower risk to utilities. It's a shorter program. It's a lower cost. It'll get the road open faster. It's got a lower maintenance cost for anybody who looks after masonry bridges that have waterproofing membranes. It's got a low embodied carbon compared to building a new bridge in concrete. And it's got a shorter duration of obstructing the river regime with obstacles. So in other words, it's a win all round. And that's what minimal intervention is. I'd love to, sit here and sell you a new bridge, but I don't think it's the right answer. And I go back to that graphic earlier in the presentation, which is the embodied carbon. We just need to save 1%. Well, this repair saves more than 1%. Third one is the Trinidad Warehouse. This is in the island of Trinidad. There was a fight for the site visit for this one. And the red rectangle is the client's plot of land. 2 buildings next to it at very varying stages of completion. And the thing here is that the client wants to build a warehouse that ultimately becomes flats for rental when they don't need it as a warehouse, so multi-use. The land slopes slightly from the left of the image to the right, and is prone to flooding because it's not far from a protected lagoon, wildlife protected lagoon. So it is prone to flooding. It's low-lying stuff. And the neighbors are all acquainted. So all those houses you see in the background, they all know each other. Other consideration, the neighbor, the immediate neighbor, the one with the grey roof there, spent 250k sterling, obviously in local money, for that property. But my client only has 100k. So how do we do this? He wants a building of the same size, maybe not the same finishes, but the same size. But he's only got 100k, minimal intervention. The other thing to factor in when I talked about politics or ego was that last bullet point. The local building control are not receptive to new ideas. And if anybody on this call has built or designed anything in a foreign land where local engineers like to hold their own, they'll know what I mean. So, what's the problem? Well, it's a clay soil. That's the dry cracking on the top right there. And we can see that the arrow that shows where it's prone to flooding. The neighbor, the one with the house immediately with the grey roof, built up their land to create a high spot. See, that's how they got around the flooding. So they built it up with imported fill. But that's not consolidated. It's unconsolidated. So as a result, they've got to introduce piles because you can't. They're not going to get a decent bearing capacity. And I want us to just eject from our minds, put aside any thoughts you may have of ground improvement, rollering, dynamic compaction, anything like that. This is Trinidad. So he's built up, he's introduced the cost of piles to get around the fill that he's imported. Local building control always expect piles, and that's their standard. We want to see piles. But are piles the right answer? Why do you want to see piles? So they want to see a ground beam, grillage, and suspended slab. That's all they know. And local builders only favor reinforced concrete. They don't know anything else. So this is the environment which we've got to find a solution that fits 100k. So what do? Well, we work with a local partner. That's the first thing. We don't try and come in as the big I am. And so we've got a local partner over there who is sympathetic to what we're trying to do, but will interpret what we're trying to do to local building control and massage that ego. We designed the ground floor with suspended slabs on ground beams with local pads, so we can do that. The main building, we designed a structural steel for long span, it's column-free openings. Now, the sketch on the page shows columns, but that's because the local partner suggested it, and we're saying, you don't have to have it. And his question was, well, are you sure about that? Well, yeah, I mean, we can model it so that it's like a portal frame. And so we'll do it in steel, and a local fabricator that does B&Q sheds will do that. We designed the ground floor walls, and this is the bit that's minimal intervention. Why build up the land to be a high spot in a flood when you can sit in a dry bathtub? So we designed the ground floor walls to be to the windowsill level as a concrete tub with waterproof door openings, reverse swimming pool, and so flooding is not an issue anymore. So we don't have to import the fill, we don't have to create piles, we don't have to do any of that stuff. Minimal intervention. We offer a few inefficiencies to massage the ego of the local building control if we have to, but that's a small price to pay. Finally, to show that this is not just on existing structures or structural engineering, we worked, Freeform Lighting, the sister company, worked for the last few years with the Institute of Lighting Professionals to rewrite the code of practice for the management of lighting assets throughout the UK. And it was launched last year. So immediate thoughts on public lighting in the UK. Well, there's approximately 12 million of these things stuck in the ground. And they don't have to be lights. They could be anything. If you think of anything metal that's stuck in the ground with a load on the top, sign, lamp column, power line, telephone line, anything, railway sign. It doesn't. It just has to have a load on the top. There are 12 million lighting columns in the UK, much less anything else. Constantly reducing number of experienced lighting asset managers. That means certainly in the UK. I don't know about other countries, but we've got a dwindling resource of experienced lighting guys that run these departments for local authorities, and so they don't have the experience, the prowess, to make the judgment call. Depleting budgets, that's being slashed, especially in this day and age. We've had the crash in 2008 and had austerity in various parts of the world for the last 10 years. Depleting budgets, lowering GDP. Statutory requirement to maintain safe assets. They've got an obligation to keep these things safe. It doesn't matter whether they have the money to do it or not. It's a statutory obligation. And lighting managers don't have the understanding of structural behavior. And that's a key point why we got involved. Because the question is, what has structural engineers got to do with lighting? And that's because they're now seen as minor structures. The new code of practice shows them as minor structures, as we'll see in a minute. But lighting managers in court, in a landmark case, the judge, or it was a judge, took the lighting professional to task in the dock, who looked at a light column and said it was safe before this person rammed their car into it and it failed. And the judge asked the lighting chap, so you thought it was safe 2 weeks ago? And he said, yes. You thought it was structurally safe? And he said, yes. And you're a structural engineer? He said, no. Well, you're not qualified to make that judgment, are you? So from that, there was a big rethink, and we got involved in rewriting the code of practice. The code of practice, COP, the previous one was TR22, which was prescriptive. The lighting industry has grown up on a diet over the last however many decades of do this, do that, do the other. This is how you're going to do it. This was at odds with recent highway code of practice, which is highlighted there as well-managed highway infrastructure, quite a separate document, which became risk-based. So part of the industry was going risk-based, and TR22, the lighting one, was still prescriptive. Routine maintenance tended to be based on repeat of previous years. So local authority guys would only do what's been repeated in previous years, whether it was right or wrong. They didn't know the difference. Results from inspection and testing only gave rise to immediate works. In other words, testing says chop down a column, that's what you do. But there wasn't any life cycle planning. Minimal intervention. How can we reduce intervention but keep stock levels high, quality, stock condition? Well, this is how we did it. And then as we come to the end. So top left, some of you may be familiar with the graphic there, which is ALARP, as low as reasonably practicable, from the Health and Safety Executive in the UK. And I've got two lines in there, one called Network Rail in the UK and one just rural. That middle zone is where you want to be, because that middle zone is acceptable risk. Down the bottom is I never want this to happen. It's a very expensive place to be, and railways tend to be there. Certainly in the UK, the aviation industry tends to be there. We're going to spend a lot of money to make sure we don't go into, we don't want it to happen. The rural is, I don't mind things happening because I can manage that risk and take steps to deal with it. So what we did was introduce a risk-based approach. So we reauthored the code of practice, introducing a risk-based approach. We created a nationally comparable index, didn't exist before, which are those little dashboard dials you can see there on the right of your screen. So in other words, before you couldn't compare region to region in the UK, but now you can, because we've stripped out local factors and made it completely comparable condition to condition. We applied a deterioration of materials, structural engineering and metallurgy, to determine life cycle planning. We developed cost modeling, we're saying that this should intervene based on a strategy and not reactive. In other words, this new code of practice will give you the information, or if you do these things and use these tools, you'll have the information to intervene on an investment strategy basis and not just because something's about to fall down. So what did that give rise to? The new document is on the left there, And you can see after the word toolkit, it says minor structures. That's a leap forward by itself to a lighting, to the lighting industry. Before it was just lighting columns. The image on the right is the April issue of Lighting Journal and the Highway Electrical News, two publications in the UK. I know they're online as well, and we've just written an article in there about the application of these lighting principles. You'll find that in there. But essentially, as time draws down, we launched a new code of practice at the institution's summit in 2019, last year, and have subsequently published articles on how to use it and the benefits and case studies, which is the graphic on the right there. That particular graphic, I don't know how clearly you can see it, but you'll see on the top graph a red line and a blue line. Well, the blue line is what a local authority was going to spend. So the first hump was this is what they planned to spend. The second hump they didn't know anything about. They had no idea that their assets were going to deteriorate to the point where that second wave or tsunami was coming their way. That's what this does. That's what life cycle planning will tell you. We suggested the red line, and the red line gives them everything they want, but saves them £10 million over 24 years. Not bad. So we encourage asset owners to apply asset management principles, develop tools to determine carbon footprint for differing intervention strategies, climate emergency again, and develop tools to determine column capacity for adding equipment to columns. That's a big thing in the UK right now. So as we draw to a close, it's not just structural engineering. It's the application of the thought process to what do we really need to do. Remember that 1% saving from structural engineers, and we can make a huge impact on climate emergency. So in summary, minimal intervention, I think, starts at the conversation with the client. It challenges the client's brief and distills their key goals. Remember, I think there are two extremes to be avoided, one of which is take on board absolutely everything they're saying and ignore them completely. It filters all decisions through the key goals. Certainly on the Newquay Footbridge that we got the award for last year, we had a very stringent set of goals, and everything was being filtered through that. And if it made the grade, then it got through to the final project. It may be affected by external influences, politics, somebody's ego in another country maybe, that says that I want to see a pile because they should always be there. You can't avoid those. But ultimately, it always feels like the right answer. Not the right answer that makes the most money, not the right answer that gets the best headlines, but it just feels like the right answer. And so I'll leave us with this. One of my favorites.
Okay, people, listen up. People upstairs handed us this one, and we got to come through. We got to find a way to make this fit into the hole for this, using nothing but that.
I thought you'd enjoy that. I hope you enjoyed that. That was one of my favorite. It's definitely my favorite movie. It may be a little bit on the emergency side of things, but it gets the point across. We have time for questions now, and I know there are some of the questions that have come through that we'll take on and answer. If you don't get your question answered, or you think of something that you wish you'd asked, we've got the hashtag, the Twitter handle there at F4M Consulting or Freeform Consulting. Just drop us a line, and we will answer all the questions, whether you think of it now or otherwise. So I will now hand back and take on the questions.
So Tony, the first question we had came in from Human, and he has said, only 25 to 50% of the commissions are coming directly from the client. The rest is part of the design and the build team. Now, unfortunately, structural engineers do not have any direct relation to set the strategies with the client. Do you agree?
I think it's a good question, and I can see where Human's coming from. I don't think I wholly agree that we are powerless on commissions that don't come directly from clients. We've got a project on the books now where it's coming from architects informed by their own engineers, and we have inherited a tender package, and it's been worked on by a very competent set of engineers, but we have disagreed with some of the conclusions they've come to. We happen to be part of a design and build team, so we're effectively assisting the contractor in putting forward contractor proposals that really talk about minimal intervention and saying why do we need to do this? It's not questioning the architectural prowess. I think Peter Rice, one of the most brilliant engineers we could possibly come across, because he empathized with architects. I think he was the only engineer to win the gold medal, the Reba Gold Medal. He had such an empathy. We're not questioning what the architect is trying to achieve. We're saying how do we get there, and do we really need that piece of steel to be there? Because if not, we're not going to put it there. So I get the point, but I think we still have a role to challenge and say, why is this? If we're overridden, we're overridden, but we have a role to challenge.
Thank you. So the next question comes from Tony, and Tony's asked, on the Trinidad project, can you explain further what inefficiencies you offered in detail with the local building control ego?
We haven't got as far as discussing anything with local building control because it's early days with the project. We know it's coming. We know that from dealing with our local partners and having some knowledge of the environment, meaning the working in Trinidad, what to expect. So we've got a few things up the sleeve, as it were, that the client considers affordable, that he can get his head around, that is a SOP to building control. Things like, to give specifics, we would offer piles because they're short. There'll be short piles. They're not going to be augured or bored. It isn't going to be necessary. So something quick and cheap that we can give them to do that. We haven't fully decided what they would be, but that's a conversation I would have with the client and my local partner to have up the sleeve as a quid pro quo. Okay.
Thank you. The next one comes from Chelvy, and it's quite a long one. First of all, it says, thank you for an interesting presentation. And the question goes on, the UK structural examples given fall under the category of better or effective asset management, repair and sweating. When can durability and design risk assess and reuse or include structural parts of existing structure in new structural solutions, i.e. not retain facades but say foundations, in his experience, clients say their insurers are not willing to underwrite such solutions. What is your experience in challenging this?
In challenging, I take it, I think it's challenging the reuse of foundations. I have come across a project where foundations were reused, but not on a building that had come to the end of its useful life. It was actually a building that collapsed mid-construction and had to be scrapped. But dynamic load, the foundations experienced dynamic loads, and so they had to load test the foundations to demonstrate, and I think they also did some ultrasonics to demonstrate that the foundations were fit for purpose. The building was allowed to go ahead. It's not our project. It was something I read about. So I'm aware that there are methods to demonstrating something can be reused. In the 3-span bridge project, we went through the whole shenanigan of doing the photogrammetry to do this, to prove that a part of a masonry structure that had collapsed did not adversely impact a part of the same structure. And so it is possible to do it satisfactorily, not always. But I do think, again, coming back to Human's question about the commissions directly from clients, we won't always win the day. But I think we have an obligation to challenge the thinking that prevails, that says it's a masonry structure, it fell down, we have to chuck the whole thing in the bin. I just don't agree with that. And one of the questions was from the client's engineers who tried to push for the new bridge was, there are unknown defects. And I said, well, if they're unknown, how do you know them? So I think it is possible to challenge these things. Just out of interest, I'd be interested if Chalvi Nava could confirm whether they had anything to do with South Bank University. It'd be interesting. It's a name I recognise. Next question.
We will see if Chalvi does reply.
Yes.
So while we wait for that one, another question from Human. Larger buildings with larger spans, but with less materials, need more stiffness to compensate the basics of the physics. How do you address that?
It's to do with the local economies. So if we take I presume we're talking about the Trinidad project, but on something like that, we're doing a costing exercise now between reinforced concrete, which is used mahusively throughout Trinidad, and its steel counterpart, which is used on industrial buildings. So the technology does exist and the welders do exist, but isn't used at all really on residential structures. Even though this is a warehouse, it is going to be a residential structure eventually. So we are doing a costing exercise. We do believe that the savings in shuttering, program, prelims, and all of the things I could yark on about compensate for the increase in stiffness that you'd get from a steel connection. And so that's how it's an offset. But any bit of concrete saved is compared to steel as a material. I go back to carbon footprint. I go back to the diesel guys use to get to site. How often are they on site? How long are they there for? It all counts. We've got to think almost like Formula One teams, the minimal margins.
Great. We have had a reply from Chalvi, and she actually said that yes, she did lecture there, Tony. So for your information, yeah.
Then she was my old lecturer.
There you go.
Okay. Next question.
Next question comes from Joseph, and he's a very simple question, really, or maybe not so much. At what point will an intervention be classified as minimal?
Minimal intervention. It's not, as I said before, it's not something that we can codify like BREEAM or, excuse me, or like, I don't know, a WIN code or something like that. It's just the application principles. It's one of those things where we'll never get to the bottom. One person's minimal is not the same as another. It really is what we should be striving for. It's when your head hits the pillow, are you happy that you've got the right answer? Now, the right answer for you may be satisfying a client who's got political problems, or satisfying a client who's got a budget issue, or satisfying. It doesn't matter. It's just about what is the right answer. Because that's the point at which minimalism is hit, or being minimal has hit. Because if you took anything more away from that, the project probably wouldn't go ahead for a variety of reasons. So it isn't something hard and fast like that, but it is something that we can strive toward and say, do we really need this? If it satisfies a political question that is not going to go away, yes. If it satisfies a costings question that isn't going to go away, then yes.
Thank you. Next question we've got Hannah. It's quite a broad one. She asks where you can go into a bit more detail about the interaction with these clients that you've worked with, to kind of to give it. I'll expand upon it a little bit. I guess it's to ask or to show how those conversations kind of go, and how you approach those with a client when they've had, as you said in one of the examples, they've had, or in your opinion, they thought they've been advised badly. If you can expand upon that whole kind of interaction, that whole process.
There are two people on the call I'm going to bring in. Yes, I can expand on that, but I think rather than me hypothesize how a client would have dealt with that, we can ask the clients. So we've got somebody on the call called Casper, and he's the client for Newquay Harper Footbridge. And I'm going to ask Casper, how did you deal with somebody coming into your sphere, an engineer coming into your sphere saying, I don't really buy or believe what you've been told before, let's look at it another way. How do you deal with that?
Yes, thank you, Tony, and good evening, everyone. So as you said, we are the lucky owners of the Newquay Harper footbridge, and we had previously been advised that we would have to replace essentially most of the bridge, including the catenaries, and we just took that at face value. We weren't very happy with the way we were being told we would have to replace it, and we found ourselves talking to Tony and team and really just wanted a second opinion on how to replace it. And he came and had a look, went away, came back and wrote a report, and to our surprise said, you don't need to replace those catenaries. And at that point I rather kicked myself, because although now we're clients of your great profession, the structural engineering profession, I spent many decades as a professional advisor in a different profession, and I used to give lectures on how clients would ask the wrong question, which is just true. We're not experts. So having been on the advising side and the client side, it is true. Clients just ask the wrong question because we're not experts. And to get to the right answer, you need to ask the right question. And therefore, I completely endorse what you were saying earlier, Tony, which is you need, as advisors, to avoid the two extremes. Don't ignore the client, of course, but also don't just accept everything the client says. We had got the wrong idea in our heads because we'd been advised that we had to replace the catenaries. When you came back and said, actually, these catenaries have many years of life left. What you need to do is what you need is a different solution. Essentially, replace the hangers, do them in a different way, and then put in place a strong asset management program. The answer to your question is we were delighted, of course. But top tip for everyone listening really was don't just take on board what the client says, because we quite often ask the wrong question.
Brilliant, thank you. And I'd also like to bring in another client that we have on the call, Matthew. And Matt was the client for the 3-span bridge that collapsed because of the flood event, and was told by his client that it couldn't be economically repaired. And so we come along, and we've got a long history between Matt and myself. And we said, no, actually it can be repaired. So Matt, how did you deal with that information?
Yeah, thanks, Tony. Evening, everybody. Yeah, it was, for us, it was just looking at what our clients' clients, which was the local residents. This bridge was now out of action, and it really, the main criteria was to get the bridge back open as quickly as possible, and to stop affecting the flood capacity of the river, the bridge over the river as well. So for me, I think we worked closely together, and we started looking at this and asking ourselves the questions, as Casper says, trying to ask the right questions, to try and make sure that we kept coming back to this sort of the brief, if you like, to get the bridge open as quickly as possible, to get traffic running over it again, to get the community being able to use the structure again, and get out of the river and stop impacting the river as well. So I think that's, from our point of view, we needed to be making sure that our client was looking at that what they were telling us. They were telling us we must get this bridge open again as quickly as possible, but that they were poorly advised, and we're looking at potentially a new structure, and we felt that we could tick all of the right boxes. Once we started talking about it, tick all the boxes, to do it at a lesser budget, on a lower cost. We could get the structure open quicker. We could get the capacity back for the river, and less impact on the environment as well. So I think it is that making sure that people are not just taking the first answer they're given.
Yeah, and thanks for that. And I think that hopefully feeds into the questions that have been asked. There you've got a contractor, that was the 3-span bridge, and a direct client, which was the Newquay Harper Footbridge. So it isn't a case that we can only challenge if we have direct commissions from a client or end client. We can go right up the chain. It just is the point at which our challenging the status quo stops, and that's your minimal, because you're not going to get any more than that. So I hope this has been of interest to you. And I'm going to hand back to Michael.